Welcome to Parents Domain.
12 Simple Science Experiments for Little Kids. If you're looking for ways to spark your child's curiosity about science, try these 12 simple activities. Children are natural scientists, driven by a curiosity to touch and explore everything around them. They learn about the world by doing poking puddles, mixing mud, and stacking blocks. Every day is a grand experiment. You can tap into this innate sense of wonder without a fancy lab. With a few everyday items, you can create amazing experiments that teach your children about chemical reactions, plant biology, and physics. Engaging in science isn't just entertaining, it also helps develop crucial lifelong skills. Critical thinking. Children learn to ask questions, form hypotheses, a good guess, and test their own ideas. Curiosity, exploration. Activities ignite the why and how questions, encouraging a mindset of discovery. Communication skills. Kids learn to listen, articulate their thoughts, and explain what they are observing. Problem solving. When experiments don't go as planned, children learn to adapt and find solutions, just like real scientists. Patience, resilience. Some processes, like growing crystals, take time and teach the value of waiting and observing. Data-driven conclusions. Children learn to use what they see, their data, to support their conclusions, like saying, "The rice is dancing because bubbles are pushing it." Healthy skepticism. A scientific mindset helps children question and investigate the world around them. By nurturing this sense of wonder, parents can lay a foundation for a lifetime of learning. If you're ready to spark your child's curiosity, try these 12 simple activities you can easily do at home. 1. Rainbow Walking Water Experiment. This magical experiment uses just a few supplies to demonstrate capillary action. Watch as you create a bridge for water to walk across, mixing colors to form a beautiful, living rainbow. The science explained: paper towels are made of tiny plant fibers. Capillary action allows water to seemingly defy gravity and travel uphill along the paper towel bridge. This happens because water molecules like to stick to each other, cohesion, and to the paper fibers, adhesion, pulling the water from one cup to the next. Materials: 6-7 clear cups or jars. Water. Red, yellow, and blue food coloring. Paper towels. Instructions: arrange the cups in a line or circle. Fill every other cup about 3/4 full with water. A, G. Cups 1, 3, 5, and 7. Add red food coloring to the first and last cups, yellow to the third cup, and blue to the fifth. Fold a paper towel into a thick strip. Place one end of a paper towel strip into the first cup, red water, and the other end into the adjacent empty cup. Continue this process, connecting each cup with a paper towel bridge. Over the next hour, you'll see the colored water walk along the paper towels into the empty cups, mixing to create secondary colors. Why it's great! Teaches primary color mixing and the physics of capillary action. Develops observational skills and patience. A perfect opportunity to make simple hypotheses. What color will appear in this cup? 2. Invisible ink. Using turmeric. Every child loves being a secret agent, and this experiment lets them write and reveal hidden messages. This version uses a natural indicator, turmeric, to reveal a message written with a baking soda solution. The science explained: baking soda is a base. Turmeric contains curcumin, a natural pH indicator that changes color when it contacts a base. When the yellowish turmeric solution is painted over the basic baking soda message, a chemical reaction occurs, and the curcumin turns a deep red-brown, revealing your secret words. Materials: 1 TBSP baking soda, 2 cup water. For the ink: cotton swab or small paintbrush. White paper: 1 TSP. Turmeric, TS, 2 cup rubbing alcohol. For the developer: a larger paintbrush or sponge. Instructions: create ink. Mix the baking soda with water until it dissolves. Write a message. Dip the cotton swab in the solution and write a message on the paper. Let it dry. Set the paper aside until the message is completely dry and invisible. In a separate bowl, mix the turmeric with the rubbing alcohol. Reveal the secret. Once the message is dry, gently paint over the paper with the turmeric solution. The hidden message will magically appear. Why it's great! Introduces children to natural dyes and basic acid-base reactions. Promotes fine motor skills through writing and painting. The magic of the reveal sparks excitement and wonder. 3. Crystal stars. This beautiful experiment is a lesson in patience and chemistry that results in a sparkling keepsake. Kids will be fascinated as they watch crystals seemingly grow out of nowhere on a simple pipe cleaner shape. The science explained. When you dissolve borax in hot water, you create a supersaturated solution. Hot water molecules are spread out, allowing more borax to dissolve. As the solution cools, the water molecules move closer together, and there's less room for the dissolved borax. The excess borax recrystallizes onto the pipe cleaner, forming beautiful crystals. Materials: pipe cleaners, a wide-mouth glass jar, a pencil or craft stick, string, boiling water, borax powder. Instructions: shape a pipe cleaner into a star or other design, ensuring it can hang inside the jar without touching the sides. Tie a string to the shape and tie the other end to the middle of a pencil. Adults only. Carefully fill the jar with boiling water. Add borax 1 tablespoon at a time, stirring until no more will dissolve, about 3 tablespoons per cup of water. You can add food coloring if you wish. Carefully lower your pipe cleaner shape into the solution, resting the pencil across the jar's rim. Place the jar in a quiet spot for 24 hours. The next day, gently lift your sparkling creation out and let it dry. Why it's great: encourages patience and long-term observation, teaches basic chemistry concepts like solubility and saturation, creates a unique keepsake kids will be proud of. 4. Rainbow rain clouds. This mesmerizing experiment provides a clear visual for how clouds hold water and create rain. It's an excellent way to begin a conversation about weather and the water cycle. The science explained. The shaving cream acts as a cloud, and the clear water below represents the air. Like a real cloud, the shaving cream can only hold so much water, food coloring, before it becomes too heavy. Once saturated, gravity pulls the food coloring down through the shaving cream, creating colorful rain. Materials: a clear glass or jar, water, shaving cream, foam kind. Food coloring: a dropper or spoon. Instructions: fill the glass about 2/3 full of water. Spray a generous layer of shaving cream on top to form a fluffy cloud. Using a dropper, add drops of food coloring onto the top of the shaving cream cloud. As the cloud becomes saturated, watch as the rain begins to break through and stream down into the water below. Why it's great: provides a simple, visual explanation of the water cycle. A quick and easy DIY project using common household items. Sparks conversations about weather, clouds, and nature. 5. Make your own hovercraft. This experiment is guaranteed to impress. By transforming an old CD and a balloon into a working hovercraft, you can demonstrate fundamental principles of physics in a way that feels like magic. The science explained. This experiment demonstrates air pressure and friction. The escaping air from the balloon creates a cushion of high-pressure air beneath the CD. This cushion lifts the CD slightly, dramatically reducing the friction between the CD and the table. With little friction to slow it down, the CD can glide smoothly across the surface. Materials: an old CD or DVD, a pop-top lid from a water bottle, a balloon, strong glue or a hot glue gun, adult supervision required. Instructions: glue the pop-top lid securely over the hole in the center of the CD. Ensure the seal is airtight and let it dry. Close the pop-top lid. Blow up the balloon and pinch the neck to keep the air from escaping. Carefully stretch the neck of the balloon over the pop-top lid. Place the hovercraft on a smooth, flat surface and pull up the pop-top to open it. The air will rush out, allowing your hovercraft to glide. Why it's great: a hands-on physics lesson about air pressure, motion, and friction. Boosts creativity and problem-solving skills. Encourages engineering and design thinking. 6. Magic milk. This classic experiment creates a mesmerizing tie-dye explosion of color with just a few kitchen ingredients. It's an easy-to-see demonstration of chemical reactions that provides a wonderful sensory experience. The science explained. Milk contains fats, and its surface has surface tension that holds it together. Dish soap is designed to break up fat and surface tension. When you touch the soapy swab to the milk, the surface tension breaks, and the soap molecules race around to connect with the fat molecules. This rapid movement sends the food coloring on a wild, swirling ride. Materials: a shallow dish or plate. Whole milk, higher fat content is better. Food coloring. Liquid dish soap. A cotton swab. Instructions: pour enough milk into the dish to cover the bottom. Add a few drops of different food colors to the milk. Dip the end of a cotton swab in dish soap. Gently touch the soapy end of the cotton swab to the surface of the milk and hold it there. Watch in amazement as the colors burst and swirl. Why it's great: an immediate and clear demonstration of chemical reactions. a fun and colorful sensory experience. Encourages experimentation with different types of milk. 7. Dinosaur dig. Transform your backyard or kitchen into a prehistoric excavation site. This sensory activity combines imaginative play with a simple lesson in paleontology as your child carefully digs for hidden treasures. The Science Explained. This activity uses oobleck, cornstarch and water, a non-Newtonian fluid. Oobleck acts like a liquid when poured, but behaves like a solid when pressure is applied. This unique property makes it fascinating to explore, simulating the patience a real paleontologist would need to excavate fossils. Materials: a large bin or tray, cornstarch and water, small plastic dinosaurs. Tools for digging: small paintbrushes, spoons. Instructions: place the plastic dinosaurs in the bottom of the bin. Pour a box of cornstarch over the dinosaurs. Slowly add water, about 1 part water to 2 parts cornstarch, and mix with your hands until gooey. Let the mixture sit for a few minutes. Now the dig can begin. Let your child carefully excavate the dinosaurs like a real paleontologist. Why it's great. Combines sensory play with imaginative learning. Introduces basic concepts of fossils and paleontology. Improves fine motor skills and concentration. 8. Color-changing flowers. This simple and beautiful experiment uses real flowers to demonstrate how plants drink water. Your child can watch as plain white petals transform into vibrant new colors, offering a tangible lesson in plant biology. The Science Explained. This experiment also showcases capillary action. Plants have tiny tubes in their stems called xylem, which act like straws to pull water up to the leaves and petals. By placing the flowers in colored water, the dye is drawn up the stem and deposited in the petals, changing their color. Materials: white flowers, carnations, or daisies work best. Clear jars or glasses. Water and food coloring. Scissors. Instructions: fill each jar about halfway with water and add 20-30 drops of food coloring for a vibrant hue. Adults only, trim the flower stems at an angle to create a fresh surface for water absorption. Place 1 or 2 flowers into each jar of colored water. Observe the flowers over the next few hours. You should start to see color appearing on the edges of the petals. Why it's great. Explains plant science in a tangible, visual way. Connects children with nature and biology. Sparks interest in how living things grow and function. 9. Dancing rice. This fizzy experiment shows what happens when you mix an acid, vinegar, and a base baking soda. The resulting bubbly reaction is powerful enough to make grains of rice dance up and down in a glass. The Science Explained. Baking soda and vinegar react to create carbon dioxide CO. 2. City mist gas. The same gas in fizzy drinks. Tiny carbon dioxide bubbles get trapped on the rice grains, acting like tiny life preservers and lifting them to the surface. When the bubbles pop at the top, the rice sinks back down, only to be lifted again by new bubbles. Materials: a tall, clear glass. Water. 1 TBSPU baking soda. 1-2 TBSPU uncooked white rice. White vinegar. Instructions: fill the glass about 3/4 full of water and stir in the baking soda. Add the uncooked rice. Slowly pour in the vinegar and watch the reaction begin. The mixture will bubble and fizz, and the rice will begin to dance up and down. Why it's great. Clearly explains basic chemistry concepts like acids, bases, and reactions. Provides a fun sensory experience with movement and sound. Encourages curiosity and cause and effect thinking. 10. Skittles Rainbow. This is perhaps the quickest experiment on the list, but its results are breathtaking. With just a plate, some candy, and warm water, you can create a stunning rainbow that demonstrates the science of diffusion. The Science Explained. Skittles are coated in food coloring and sugar. When warm water is added, the sugar and coloring dissolve. Diffusion is the process where molecules move from an area of high concentration to low concentration. The dissolved color and sugar from each Skittle move through the water towards the center, creating a vibrant rainbow. Materials: a white plate with a slight rim. A bag of Skittles. Warm water. Instructions: arrange the Skittles in a circle around the edge of the plate. Carefully pour warm water into the center of the plate until it just covers the Skittles. Watch what happens. Within seconds, the colors will travel toward the center of the plate, creating a beautiful rainbow. Why it's great. Demonstrates the scientific principle of diffusion. A very simple and quick setup with a delicious potential reward. Provides fantastic visual stimulation for young minds. 11. Silly Glove Guy. This playful activity is an exploration of physics, challenging children to think like an engineer to make a floppy glove stand up on its own. It's a fun way to experiment with balance, weight, and center of gravity. The Science Explained. This is a hands-on lesson in physics. To make the glove stand, a child must learn to distribute its weighted filling so the base is wide and heavy enough to support the top. They are intuitively finding the glove's center of gravity and lowering it to make the structure stable. Materials: a disposable rubber or latex glove. A filler material: uncooked rice, beans, or sand. Markers to decorate. Instructions: let your child decorate the glove with markers to give their silly guy a face. Help your child fill the glove with the chosen material and tie a knot at the end to seal it. The challenge: can they make it stand up? Encourage them to squish and move the filling around until it can balance on its own. Why it's great. Teaches physics concepts like balance and equilibrium in a fun way. The silly nature of the activity is sure to produce giggles. Improves fine motor skills and creative problem solving. 12. Ice cream in a bag. Yes, you can make real, delicious ice cream in minutes using science. This edible experiment demonstrates how salt affects the freezing point of water, a principle known as freezing point depression. The Science Explained. Water freezes at 32° F0 Gauss. To turn the milk mixture into ice cream, you need to get it colder. Adding salt to ice dramatically lowers its freezing point, making the salt-ice mixture super cold. This super cold brine quickly absorbs heat from the milk mixture, causing it to freeze into ice cream as you shake it. Materials: 1 large and 1 small resealable freezer bag, 1 2-cup milk or cream, 1 TBS-poo sugar, 1 4 TS-poo vanilla extract, 3 cups ice and 1 3 cups salt, kosher or ice cream salt, oven mitts or a towel. Instructions: in the small bag, combine the milk, sugar, and vanilla. Seal it tightly. In the large bag, combine the ice and the salt. Place the small sealed bag inside the large bag. Seal the large bag tightly. Wrap the bag in a towel and shake vigorously for 5-10 minutes. Carefully remove the small bag, rinse off any salt, and enjoy your homemade ice cream. Why it's great! Deliciously combines cooking with a science lesson. Provides a tasty reward for your child's effort. Teaches practical skills like measuring and following a recipe. Science is all around us, and with a little creativity, you can turn everyday moments into exciting discoveries for your child. Try out these experiments, enjoy the wonder together, and watch curiosity grow into lifelong learning. Don't forget to visit parentsdomain.com for more fun ideas and activities. Until next time, see you!